This conference will now be recorded.
All right. Morning, afternoon, evening, everyone. Thanks for joining the bi-weekly door heat exchanger call. Let me just quickly share my screen. Um, hmm. Okay, can you all see my screen?
Yeah.
Yep, I can.
Okay, great. We have a few items to go over the agenda. Yeah, including talking about the global summit. Don sent an email out, and then we have updates in different focus areas. Sankar has to drop off the call in about 5 to 10 minutes. So, Sankar, do you wanna go first? I can, since I have my
Yeah,
screen
sure.
shared, I can pull up the document if you want me to.
Yeah, that's fine. Yeah. Okay. So thank you, John. Let me see if I can zoom in. Okay,
Oh, I can zoom in. There you go.
that's fine. I got it. Yeah. Okay. So, team, this is for the microchannel heat exchanger to be used as a rear door heat exchanger, a white paper that we discussed a few weeks or maybe a couple of months ago. We just submitted the abstract for that for the OCP Global Summit and started working on the white paper. So here's just a draft of this. This is in no way um, I wouldn't even call it a first draft, but just a points that is going to come in this white paper that we are going to deal with. So the first part, a few sections is coming from a um, uh, different contributor. So I just left it blank here. So we are going to have a section on background on rear door heat exchanger. Um, if I move, I don't know if I'm moving here, so I don't know if others can see what I.
Yeah, we can see it.
Okay, I don't know where you can see. Uh,
Yeah, so actually, Sankar, I'm actually sharing my screen. So I took it up because you were talking about what's coming from where. So I can go back down,
okay.
scroll down
Yeah,
to
yeah,
the.
yeah. Yeah. So as John is showing, we have three contributors for this white paper. I'm from Danfoss, and we have Boyd and of course Meta. So we kind of will have three people from one from the heat exchanger manufacturer, one from the actual OEM, and one from the actual end user. So I think that would give us a comprehensive view of all the challenges, all the requirements for this application. So, John, if you could go back to the other.
Yep, I'm back in the section where you have put some
Mhm.
input. Yeah.
Okay. Okay. So the white paper is going to be, of course, divided into multiple sections. The first section would be a little short background on rear door heat exchanger. What is the current state of the art? What technologies it uses, and things like that. Then there will be a section on introduction to microchannel heat exchangers. I realize that not many people in this industry know what a microchannel heat exchanger. Maybe when they hear microchannel heat exchanger, they first of all think of a heat sink on a chip. But that's not what we are talking here. We are talking about a like a air to refrigerant or a air to glycol heat exchanger, and we want to introduce that to the community, saying, okay, this is what we mean by a microchannel heat exchanger in this context. So I will explain various components on the microchannel heat exchanger, how it all fits together, a very short intro on manufacturing of the microchannel heat exchangers. Then I will present the advantages of microchannel heat exchangers compared to round tube plate fin heat exchanger. Uh, this I show it in multiple, one a thermal From a thermal perspective, why is microchannel better than a finite tube? And then again, on a hydraulic perspective, what it does for the airflow and what are the benefits of using a microchannel compared to a finite tube, hydrodynamically and thermodynamically. Okay, so that would I will elaborate that section a little bit more here. I just put some points here in the working paper, which I think everyone is able to see. Then these are just from the component level, what are the advantages. But when you use this technology, there are other benefits from a system level, uh, which are not very evident um, at first, but you will see the benefits of using these in a system. I mean, some of these are very important for the community, such as reduced weight, reduced um, internal volume, which would reduce all the fluid that is used. Uh, then much streamlined airflow, which would means less power draw for the fans and also less noise. So these are some of the benefits which I will elaborate. I think that's what I have put in till now. But after that, we have some performance specifications for three different types of heat exchangers. Uh, I think the aspect ratio remains the same, just that the depth of the heat exchange is different. We have a 3-row, 4-row, and a 5-row designs. Is it right? I think it is, or 4, 5, 6-row design. So we'll try to design a microchannel heat exchanger that would fit this application, and we'll compare the performance specs of the current technology and the microchannel heat exchanger in the upcoming sections. So that we are still to do that. It's not complete, but that's where the white paper stands at this point. Any questions for the community? Any feedback? What we need to add? What should not be put, or things like that? Anything is welcome at this point.
I guess very quickly, right? I don't have a lot of background with Redo applications of the microchannel, but I know that I know maintenance guys. The first thing you talk about when you talk about aluminum or replacing aluminum, replacing copper with aluminum is the repairing, because it's easier, it's more easily damaged than copper, and it's more difficult to repair. And also there's a bit of a corrosion issue. So I think it's a good idea just to take those, list them. Sorry, state them in the white paper. Just say, well, hey, we know these are common complaints, but these are the things that can mitigate that. Just so that it's not a comment that people think it's something being overlooked or ignored.
Yes, obviously. I mean, we initially thought of having challenges and also go into detail into materials and stuff, but I think later we decided that will be a little too much for this white paper.
Okay.
We think this white paper is going to be just an introduction, but I think your point about just the known issues is okay. Not going into too much detail into what kind of materials, or what are some of the challenges with glycol, interoperability with copper, technical loop, facility loop. We are not going to get into that detail in this white paper, but it's still a good idea to list some of the concerns that are on the surface.
Yeah, the case study may be a good place to just discuss. So if you could say, hey, it's being done, so you don't have to worry, that much about it.
Okay.
Awesome, Sankar. I know you have to drop, but appreciate you. Appreciate you joining the call and giving a quick update. Thanks.
No problem. Thank you very much. If you have any questions, please let me know, or let me know through John. Either way is fine. So, thank you.
Sankar, I have a question here.
Yeah, sure.
There is one point. Is in case the water is not very clean, and sometimes it's the problem in some data centers, at least in the primary loop. For this point, the micro channel are a little bit bigger than with refrigerant, normal refrigerant, like
Right.
Air
Right. So
134 or something like that. That way, the
so
cars manufacturer use a bigger tube or something like that.
yeah. So when we use microchannel in a rear door heat exchanger on a facility loop, you typically don't use the design that is used for a refrigerant application. The ports are bigger, the ports are wider, um, so you will have very less chance of actual uh, sediments being blocking the ports, because these things have been in application for quite a long time in regular HVAC applications, um, with glycol and water. So yeah, to your point, we will we will not be using a refrigerant tube design. It will be a different design.
Okay, thank you.
Mhm.
And which is the tube white for water instead the refrigerant is much
What is the
different
tube?
or
So the tube width is it depends on the capacity. How what is the capacity you want? But inside the tube, you will have multiple ports, like small ports,
yeah
um, and that ports is typically, if you are looking at a refrigerant application, you're looking at around 150 to 200 microns. But here it would be around I think 600 microns.
yeah
So that is typically the
Yeah.
difference.
These are good data points. Yeah, I think we should include
Mhm.
this in the white paper
Yeah,
eventually.
yeah, yeah. I mean, I'll have a typical cross section of a microchannel tube used for these
Refrigeration.
applications.
Yeah, yeah, yeah. Nice. Um,
yeah.
awesome. Thanks again, Sankar, for the quick
No problem.
update.
No problem. Thank you
You
very
know,
much for the
we keep
opportunity. Yeah.
checking in on this. So yeah, thanks,
Okay.
Sankar, once again.
No problem. Thank you. Have a good day, guys. Bye.
So Sankar had to drop off. I think for those interested, one thing I'll do is see if we can anyone with the link can view. So I'm gonna copy the link here and put it back in the notes. Update by Sankar. I'm just gonna say tracking document here. So those interested can have a read, and everyone should have access to the meeting notes. So hopefully that's not a concern. Okay. All right. So moving back to the regular schedule, the first thing I wanted to touch on was the 2023 OCP Global Summit, talking about the latest information. So I'm not sure if the authors have received any emails already, but the intention is to provide confirmation this week, at least based on the timeline that's on the webpage, on the OCP webpage. One thing I do know is, based on the latest information I'm aware of, all the abstracts have been accepted. So just want to make sure that all the authors are aware. And then the next deadline will be the draft presentations, which will be August 25th. So Juan Carlos, I know you said you'll be out for the next 2 weeks, but I think we should have enough time to put together a draft presentation, right?
Yeah, I come back the 14th of August, so we can discuss about that after I come.
Okay.
I think in 1-2 weeks we could do that.
Yeah, I can also work with Jabari to kind of put something together, at least as a draft. So I think that should be fine.
Yeah, help a lot. Yeah, a draft, and
Yeah.
after that we can modify it. Yeah.
Yeah, it's not the final version, so it should be fine. And sorry, just give me 1 second. And the next topic, I think Don just joined, so I think that's a nice segue. Just FYI, there was an email sent out about I don't know if it was earlier this week or sometime last week, but it's basically soliciting interest and participation in an exploratory workstream under ACF around the Open TCS. So I've included a link here. Don, since you're on the call, do you want to maybe give a quick 2-3 minute pitch, if you don't mind? Don, can you hear us? Okay, I just want to make sure everyone else can hear me.
I can hear you.
Okay, very good.
Sorry, I'm jumping all over the place. This GoToMeeting pops up a little different every time. But yeah, so real quick summary. Do I have the ability to share anything?
I mean, I'm sharing your mission statement document, but if you want to
Okay.
share something.
So a couple things. There's been discussion on how can we transition from boutique to cloud scale deployment of liquid cooled ITE. And to do that, in most cases, the situation right now is that a vendor provides a CDU and a liquid to the rack solution. And in many cases, especially true with cold plate, that's all a proprietary integrated solution. Earlier this week, we actually had participation by Tim Shed from Dell, and there is movement to try to categorize ITE to support a more global solution, to try to break ITE down to a certain range of delta T's and inlet temperature kind of applications. And so this is an exploratory effort to try to see, can we commoditize or maybe open up better the definition of what a coolant distribution unit is. Because as the vision that we see in the future is many data centers will put in a coolant distribution unit and say liquid to the rack solution that goes all the way for, say, a door heat exchanger. And then 5 years from now, people may want to say, well, can we use that same CDU and distribution and support door heat exchangers and cold plate, or just cold plate? And so we're breaking that down into a series of discussions around which we're trying to. So one of the discussions is looking at a CDU and trying to figure out, do we need to categorize an 8-degree delta T CDU, or can you have a CDU that starts as 8-degree delta T and then maybe optimized in the future for a 20-degree delta T, because some ITE operates in 8 degrees centigrade and some ITE may benefit. So there's a lot of exploration, but there's several categories that we're looking at. One is the CDU discussion. The other is the door, the distribution discussion, and then the final discussion or work stream area would be around the say the branch lines, what should go into that. Can we come up with OCP recommendations? Let me pause. Does that make sense to people, or does and the mission statement we have here is there, but what we're going to need to be successful here is volunteers that want to participate in those three categories. Is there someone that is passionate about trying to optimize CDUs or CDU guidance so that we can achieve those goals? And likewise, distribution guidance, which likely would be a 4-inch or a 6-inch pipe system that could be interchangeably used. Are there questions in this? The mission statement says a little bit more. I actually have to drop off in a couple minutes, but I got 4 or 5 more minutes left if you want to open for questions or drop me a line and say you'd like to participate.
Yeah, so Don, maybe one thing you can do in the chat window is maybe put your OCP email address so folks can respond and say, hey, I'd like to participate.
Okay, and let's see, I'm trying to find there's the chat window. uh, is it okay? Sorry, I'm misspelling this.
Yeah, so while Don is doing that, if anyone's interested or hasn't seen the email that was sent out to, I think in general, just the wide cooling environments community, I just wanted to bring this up over here just to make sure that, you know, everyone's aware. So yeah, if you have any quick questions for Don, now would be a good time to ask that. And Don has posted his email address and phone number.
I have an OCP address if that people prefer, but I don't check that mailbox as much as I do my other one. Sorry about that.
No worries. Yeah. Anyone?
Don, I have a question about that. You spoke to change this technology, CDUs and so on, and move from boutique to standard technology and so on. But I think what we do here is to place the right conditions to develop products in the right way to be so to speak the same language with all suppliers and all customers. This is the way is the idea behind this group to develop the right conditions to develop CDUs. It is.
I think I understood a lot of that, and hopefully it's an agreement. But yeah, to go to cloud scale, where a world where people might be looking at thousands of CDUs versus tens and 20s of them, we definitely have to open the supply chain up a lot more.
Okay. Okay. Thank you very much.
I do have to drop off. Appreciate it. Thanks.
No worries. Thanks for the quick line, Don. Okay, moving along, back to the meeting notes. Those interested, respond to Don's email. Let me just paste the information over here. Give me 1 second. Come on. There you go. That information is both in the chat thread as well as in the meeting notes. Moving along, just wanted to touch on the different focus areas. I know, is Jared? Yeah, Jared's on the call. Hey, Jared, do you want to maybe provide a quick update? If you want, I can allow you to share the screen, or just let me know how you want to drive this.
Yeah, I don't have any content to share on the screen because, of course, I'm still in work here. But the update I can provide is just on getting some clarification on mounting for the rear doors. So um, I do want to collect any CAD from the vendors here that do have rear door heat exchangers that they're able to share. That way I could use it as a reference for mounting and what the best mounting or most applicable mounting solution might be, as they're all different. That's the main interface that I'm focusing on now to ensure applicability.
Jarrett, can you send us an email requesting that?
Absolutely, will do. And other than that, no other updates just yet until I have some more information from the manufacturers.
Yeah, and Jared, I can provide the email email address for Benny.
Thank you. That would be really helpful. I think it's a critical point in the design where I definitely need to reference some of the different mounting options to make some more progress here.
Awesome. Yeah.
Okay.
Thanks.
No problem.
And then moving along to other focus areas. So with the modular data center and hybrid cooling white paper, we've actually had weekly meetings with Carl and David. We have discussions to use data from the OAI liquid cooling white paper. Not sure if folks have seen this before, but this has been contributed to the to OCP. Which involves end users, suppliers, cooling solution vendors. But specifically, there's a lot of information on, what passive cold plate loops look like for the UBB 1.0, which is the universal baseboard, which comes with the standard 4x2 configuration. There's a lot of information on how you lay out your PCLs. You can put them so that two cold plates are in series, or you can put them so that all cold plates are in parallel. There's data on what the pressure drop looks like, and performance information. I think a lot of this was contributed by Weaven and Cooler Master, so there's a lot of good reference design. They also have a reference thermal test vehicle. And like I said, there's a lot of performance information in here. So the intention is to use this information that already exists in OCP as part of the white paper. And then from that perspective, we're kind of looking at using that tray that has liquid cooling to look at two different configurations of what we call as a hypothetical GPU tray box. So which would be 4U. The 3OU at the bottom would be like a GPU tray, and then the top OU would be like a head node. I think there are products out there that are very similar to that. And then this is the information that we'll be using, and the intention is to see, effectively is to look at two scenarios. I think one is obviously is to maximize the amount of power in the rack. So I think, as I said previously, we're looking, based on the most recent discussion with David, it's looking like we're going to be around 60 kilowatts in the rack, which I think is a good reference point. And then for that 60 kilowatt rack, we're going to look at two different operating scenarios. One is that's based on a 10 C delta T on the cold plate or the cold plate loop, which is supported by the white paper. And then the other one is to see if you can minimize the flow rate, so you can maximize the return temperature. So David wants to look at this from like a heat reuse standpoint. I think Carl is interested in that too. So currently we've made a good amount of progress, and I think as we continue to put together the calculations, we'll share more on the door heat exchanger call. But as I've outlined over here is, we're looking at rack powers greater than 60 kilowatts. And if you look at the existing white paper that's been contributed for a modular data center, effectively you have 18 rack positions to work with. So we're thinking two of these positions will go to the CDU and the battery and the UPS for it. But then potentially you have up to 16 rack positions, basically for hardware. And based on our initial numbers, that's leading to a modular data center capacity of 1 megawatt, which is quite high. Obviously, we need to do the work, look at, okay, what does this mean for what does this mean for how much liquid needs to be brought into the modular system? What sort of overhead pipe sizing would that look like? We can rely on the ACF white paper. But yeah, we've been making a bunch of progress over here, and all three of these topics will be presented at the global summit. So I think things are coming along pretty well over here. So anyway, just wanted to provide a quick update. And yeah, if there are any questions, I'm happy to answer them. Okay. Just quickly checking in on any other topics. Jabari, with regards to concurrent maintainability, is there any further support needed, or do you have adequate information at the moment?
Yes, so we kind of wrapped up the majority of the Redo discussion today. Of course, people are always welcome to drop by and give feedback, anything they'd like to add, especially when it comes to like integrations and stuff, because that's an ongoing discussion. When I say integrations, I mean like, if you have a Redo mixed with another something that's like a cool plate, or even like chassis or something. But anyway, people are always welcome to join. I appreciate the feedback I got. We discussed in the meeting here with Tim's feedback with Benny. Some people sent their responses back by email. We got Rital, Juan Carlos, and Martin in the call 2 weeks ago to have that live discussion with them. And between all of those sources, we were able to get pull together the major information that we needed. But yeah, I mean, you guys are always welcome. We appreciate the feedback from the vendors, especially guys in the field actually doing the work, because one person's perspective is always kind of biased, right? And Uptime appreciates getting the kind of feedback that you guys have based on your experiences. So thanks, and you're always welcome. We're moving on to immersion now, by the way. That's the focus of this discussion. That's the third topology we're going to look at. And then the meat of the discussion should be completely covered. So I'm going to reach out to the immersion group next.
Awesome. Yeah, seems like that contribution is coming along fairly well. So great.
Yeah, sorry, this is Louise Avelino with Cool IT Systems. Jabari, I think you've reached out to Cam in terms of a couple questions about serviceability and where maintenance kind of takes place surrounding the cooling system. So if you did have any additional questions, I'm definitely happy to support. If you want to reach out by email, just let me know and I can jump on a call or whatever works for yourself.
Yeah, definitely. Thanks. I appreciate it. I will. I'll drop my email in the chat. And
okay.
Yeah.
Okay, sounds great. I can reach out.
All right. Thank you.
You bet.
Awesome. Do we have any other topics the community would like to bring up? We have a few minutes left. All right. If not, happy to give everyone time back. Juan Carlos, enjoy your vacation and see you when you return. Yeah.
Thank you very much. Bye bye.
All right.
Have a
Thanks
good
a
day,
lot.
everyone.
Take care. Bye.
Thanks, guys. Bye.
See ya.